we go. Kids, what do I need to remember if I'm adding fractions and they have different numbers on the denominator? What do I got to remember to do? That's what I'm going to do. I'm going to multiply them to make them improper fractions first. You're right. I forgot about that, Maria. Thank you. Times plus. So that is 5 over 2 plus 10 over 3. Now what do I have to remember when they are different? It's still frozen, isn't it? Old people in technology, am I right? My mother-in-law, she's dead now, so I'm allowed to say this. My mother-in-law couldn't even turn on her TV. So I would have to go there and turn it on because she had a cable box and all that crap. And my kids would go over there sometimes and they would play Wii because my mother-in-law got a Wii for my kids when they were little. And my kids would sometimes forget to turn it back to TV. And my mother-in-law would call me, no matter where I was, the kids left it on the Wii. And I would say, okay, Carla, pick up your remote and push and they'd say, I can't do that. And I would have to drive back to her house to push source. Old people. But here I am, not unfreezing my screen. Am I turning into my mother-in-law? Kids know let's practice. Everybody's favorite class, right? Yes. Am I turning into my mother-in-law? Yes. I see how it is. Okay. Fine. What do I have to remember when they're different numbers and I'm adding? I got to make them what? The same. And what are 2 and 3 going to work out to be the same? 6. So 2 was times 3. So what do I do to the 5? Times 3, because they're partners. Anything you do to the bottom, you got to do to the top. So that's 15. What do I got to do to 3? Times 2. So what do I got to do to 10? Times 2, because they're partners, and I got to do the same thing. And what's 15 plus 20? 35 sixths. Can you leave it like that? You can. And will I give you a B? Yes, I will. And is a B a pretty good grade? Yes. It's the second best grade you can get. So let me get this straight, Keelan. If you were in the Olympics and they brought you a silver, you would be like, nah, take that away. Depends on what? You're getting a silver in the Olympics. You'd be like, no, thank you. Really? Wow. Okay. How many of you would throw away the silver medal? What? So it's gold or nothing? Yeah. I actually agree with you, Armand. Gold, yeah. Bronze, at least I got something. But silver, that just means you lost the gold. Right? Especially in the Olympics when it's like half a second. All right, anyway. But seriously, you take back the silver medal. All right, fine. Everybody else, are you happy with the silver medal? We just said no, we want the gold. So what are we going to do with that? How many 6s fit into 30? 5. That's 30. I needed 35 6s. So there's 5 sixths left over. Right? Right. Hardest thing in math, according to calculus students. No. Jackson, this is when you say, I'm as good at math as the calculus 12 students, because they're scared of this. But you are, because you're not scared of this. The problem, Keelan, with calculus, and let me tell you this because I've done some calculus. Everyone is scared of the word calculus. Right? Like even kids that are good at math, think, oh yeah, it's hard. But if you actually understand your regular math, calculus isn't that difficult. It's just this. Again, Let me give you a different example. If I gave you a puzzle that was 6 pieces, could you do it?
Yeah.
Of course you could. You'd find the corners, then the middle. Yeah? That's how I do puzzles. And then you would find the pieces that fit together, you put it together, you'd have a picture. Yeah? If I gave you a puzzle that was 6,000 pieces, could you still do it?
Yeah, it's the same process.
Yeah, it's the same process. It's just more complicated. Yeah, it's not more difficult, is it? Same in math. If you learn the basics, then all the rest of it will come to you. But you have to actually learn the basics, not be like, oh, I kind of get it, let's move on. Picking up what I'm putting down? All right. What do I have to remember to do with division when I have mixed numerals? What's the first thing I need to do? I got to change them back, yeah? Do I care about that little negative right there? No, because I know my answer is going to be negative because a positive divided by a negative is negative. So I don't even need to care about that guy. So I'm going to white him out because screw that thing, yeah? All right, then we multiply. What's 3 times 4 plus 3? 15 over 4 divided by. What's 18 times 1? You did the next step too, Maria. 18 times 1 is 18. Plus 7. 25 over. Now what do I have to remember when it's divided by? I got to do something. I got to flip which one? I've already given it away because I started writing the first one, didn't I? Old people and technology. Times 18 over 25. Now, does anything work with 15 and 25? And does anything work with 4 and 18? Which one do you want to do first? Because something works with both of them, yeah? Should we do pink or green first? Pink? Okay, what works with 4 and 18? 2. How many 2's fit into 4? 2. How many 2's fit into 18? 9. 9 2's. What works with 15? 15 and 25? 5. How many 5's fit into 25? 5. How many 5's fit into 15? 3. What's 3 times 9? 27. What's 2 times 5? 10. And we know I need a negative. And since we're all going to throw away the silver medal, we better get the gold, right? How many 10's fit into 27? 2. With how many left over? 7 tenths. What if I told you I wanted that as a decimal? 7 over 10. So that would be negative 2.7. Yeah? Yeah. All right. Now, do this sheet. We did bed mass yesterday. If you forgot bed mass, I even left, it was supposed to be a highlighter, old people and technology. I even left the order written there for you to help you. But I don't want you to use your calculator. See if you can do it in your head. Ready? Go. This page. Go. Did you already do this page, JB? And yet I don't see your pencil moving. Now I do. Nice. Now, kids, if you need your calculator, go ahead and use it. But I'd like it if you didn't. Does everybody understand what I mean? I forgot them. God damn. Monday, Tuesday, Wednesday, Thursday. Damn it!
I thought you had 2 every day, not Saturday.
I had a 3 every day.
Oh.
I forgot to add yesterday. Remind me at 10 o'clock tonight to get gummy bears. So you all know what's going to happen tonight. My phone's going to make an alarm. And I'll be like, what the hell is that? Because old people and technology. But then it'll be 10 o'clock, so I got to go to bed because I'm old. Yeah, exactly. That's exactly what I would do, Jackson. But at 10 o'clock, I won't forget because I'll have nothing else to do. Wait a minute, I have baseball tonight. That goes till 10:30. Damn it! I'm going to try it. I'm going to see if it works. I don't take my phone up to bat. What, so I can get a nice Insta of me swinging? I don't hit home runs. That's not true. I've hit 2 home runs in all of my softball career. Over the fence home runs. If you have a field without a fence, sometimes you get a home run anyway because the guys screw it up on the outfield. Does anybody want to take my pen and my computer and fill these in for us? Maria? Yes. It's wireless. Now this is where Maria finds out that no. It's wireless, Maria. It comes to you. Choose your color up top. Go for it. This is where you find out that it's not as easy to write on this thing as everyone thinks.
Okay. First the parentheses.
You're going with blue?
Yeah.
Okay. Oh, I didn't freeze. I got it. Oh, people. Okay, go. What are you going to do first?
Add.
Okay.
Then,
Freeze. Class, is Maria right? Show of applause. Nice. Keep going. Now what are you going to do? 20 is right. Is she right? Oh my God. Now what?
okay, got it. Oh.
If you want to erase, you turn over your...
Okay. So...
Class? Uh-oh. No applause.
I
Did
did
you make a
something wrong.
mistake? Anybody want to take the computer and fix it? Oh. Maria, you're so close to perfect. What do we do first? Divide or multiply? We go left to right.
Yeah.
Gotta do this divide first, don't we?
Oh, yeah.
So what's 8 divided by 4?
Oh, sorry.
Turn it over, it works like an eraser. Maria, turn the pen over, it works like an eraser.
Okay. Yeah, I didn't see that. Sorry.
That's okay.
8.
8 20 plus 8 divided by 4 times 2. You guys see that kid? He was walking like this. That was weird, right? Like this is how we walk, yeah? But not that kid. Maybe he's hearing music in his head. Oh, he could have had one earbud in on the other side. That sneaky bugger he could have. See those kids. But I bet that other kid was having more fun. Right? Who doesn't have fun dancing? Did he turn around? Oh. 20 plus 2 times 2. And now? 20. 24. Now, class, is Maria right?
I got so confused. Sorry.
That's okay. Anybody else want the magic pen? Nobody? What if I would pay you with gummy bears? You would say, you won't, Myers. You'll forget the gummy bears and I'll never get paid. All right. Here we go. You check your work. Make sure you're doing it right. 2, 6 plus 1 minus 5. 2 times 7 minus 5. 14 minus 5. 9. Did you do it right? Did you do it right? So why aren't you applauding? Applaud for yourself. You did it right. Next one. Oh, this is sneaky. Remember? I told you it's like brackets. So that's 18 over 6 minus 3 plus 10. What math is 18 over 6? Remember, the answer to what math is always add, subtract, multiply, or divide. What math is 18 over 6? Divide. So that is 3 minus 3 plus 10, which is 0 plus 10, which is 10. Did you do it right? One person did it right. Everybody else got that question wrong because I don't hear anybody else applauding. Okay. And the last one. Oh my God, this one is so hard. This one's really hard, right? So you've got the order here. Remember, when you see a fraction thing, it's like it's in brackets. The whole thing. And if there's stuff on the top and bottom, it's like they're in brackets. So it's 3 cubed minus, what's 7 plus 3? 10 over 2. And it's like that is still in brackets. So 3 minus, what's 10 divided by 2? 5 plus 2. Now I do the exponent. 3 times 3 is 9. Times 3 again is 27 minus 5 plus 2. 27 minus 5 is 22 plus 2 and 24. Is everybody good? That one was tough. Don't get me wrong. I'm not lying. Yeah, we all good? One more time. Which part? All of it. Okay, so the key to remembering this, Karen, is that anytime you see this, it's like it's in brackets. And anytime you see something like that on top or on the bottom, it's like those are in their own brackets, right? So we got to start here. 7 plus 3 is 10, right? And 10 divided by 2 is 5, right? So, this is now 3 cubed minus 5 plus 2, right? Now 3 cubed means 3 times 3 times 3. What's 3 times 3? 9. 9 times 3 is 27 minus 5 plus 2. 27 minus 5 is 22 plus 2. And 22 plus 2 is 24. Yeah. Turn the page over. This is your next page. This is your next page. All right. Okay. I'm going to write something down that you already know. And then I'm going to show you how it helps us do way more math. Okay? It's actually probably the most important thing you can learn in a math class for this class, because we're going to do it a million times, and for real life. You're going to see how what I'm about to show you today will help in real life. So, first thing we got to do is something that you already know. 3/4 equals 6/8. And you already know that, don't you? Because 4 times 2 gets me 8, and 3 times 2 gets me 6, right? What if I did 4 times 3? Then I would have 12, and then I did 3 times 3, then I would have 9, and they're all going to be equal, and you already know that, right? So, if I wrote any fraction in the universe, so I can use any number I want, what do we use in math instead of numbers if I'm speaking of any number? We use a letter, and we always use X and Y, don't we? Do you want to hear a math joke? Hey, math, stop talking about your X. I don't know where it is, or where she is, and I don't know why she left. Stop talking about your ex because I don't know where she is or why she left. X and Y, nothing. More practice needed. X over Y is any fraction in the world, yes? And as long as I multiply those by the same number, I will keep the same value of fraction. We already know that, right? Okay. Now, because you already know that, that lets you figure out this when you don't know one of the numbers. Now, kids, you are going to use this math about 1,000,000 times in this class for this course. You're also going to use this math in physics. You're going to use this math in chemistry. You're going to use this math in biology. You're going to use this math in economics. You're going to use this math when you're shopping as a grown-up. You're going to use this math when you're trying to figure out how much you get paid, how much you need to get paid, how much you need to save, how much you need to spend. This is very, very real-life useful math. Okay? So, when we look at this, it's my man Mahip. When we look at this, there's a long way to solve this in algebra. that takes a long time. I already know that you already know how to do the long way. Right, class? Right. So I'm going to teach you the shortcut right now because it's useful. Everybody ready? You don't write down what I'm about to write down. I'm actually going to do the long way first. In the long way, whenever you see a letter and an equals sign, you want to get the letter by itself, yes? And to get the letter by itself, you have to do the opposite of what you see, right? So what math is happening right there? Divided by 18. I can see that that's divided by 18, yes? So I have to do the opposite of what I see, which is multiply by 18. Agreed? So if I multiply this side by 18, I have n over 18 equals 10 over 15. If I multiply this side by 18, those 18s are going to disappear, aren't they? And what's left over here? Just the n. Agreed? So now n equals, but if I multiply this side by 18, what do I have to remember to do to this side? I got to multiply this side by 18. Now you're smart kids. That's 18 over 1, isn't it? 18 times 10 is 180 over 15, right? Everybody agree? Now, is n by itself? Is there anything with that n? No. What math is this? Divided by. So I would have to, now, can any of you divide that in your head? Maybe. How many 15s fit into 180? 12? I'm kidding, Keelan. Yes, it's 12, right? So n equals 12. Everybody with me? That's the long way to do it. Of course, there's a shortcut, which I have right here. You multiply the diagonals. So I had n over 18 equaled 10 over 15, right? Multiply the diagonals. Now I got to tell you that the diagonals means, and I'm writing it in blue because I highlighted it in blue, means a diagonal pair. In this case, that is my diagonal pair. Does everybody see that? Then divide by the leftovers. And I'm going to write that in yellow. Divide by the leftover number. Sorry. Divide by the last. And you do it with your calculator. Now, because we're going to do this 1,000,000 times, you just use your calculator every time you see it. So everybody grab your calculator and push the buttons. 1, 8 times 1, 0 divided by 1, 5 equals. And your calculator will show you 12. Automatically. We're going to do that in this classroom probably 100, like I say, 1,000,000 times. We're not really going to do it 1,000,000 times. But if somebody says they're going to do something 1,000,000 times, it means we're going to do it a lot, aren't we? Everybody cool? And if it works once in math class, will it always work? Yes, because math doesn't mess you around like English. Tell me if I actually like Carson's football jersey right now. I'm going to say some words. You tell me what I mean. Nice jersey. What were the words? That's what I meant, doesn't it? But I said nice jersey, didn't I? But I actually meant he looks stupid, didn't I? But what if I said it this way? Nice jersey. What did I mean? That's an awesome looking jersey. Are they the same words? Did they mean something totally different? Yeah. That doesn't happen in math. It always works. Everybody cool? What if the numbers are ugly? So I'm going to write a couple here. You get your calculators out and get ready to go. Somebody give me a number between 11 and 20. 17. Somebody give me a number between 1 and 9. 8. Somebody give me a number between 20 and 30. 24, I heard. Somebody give me a number between 1 and 9. 7. Equals. Somebody give me a letter. A. Somebody give me a number between 50 and 60. 56. And somebody give me a number between 1 and 9. 8. Does this look like what we just did? Looks like it to me. Is there a fraction on one side and a fraction with an unknown on the other side? Is there a diagonal pair? What is the diagonal pair? Right there, yes? Is there a leftover number? Right there, yes? So what am I going to use on my calculator to find A? What do I do with the diagonal pair? Multiply. So I get out my calculator and I go 24.7 times 56.8. And then what do I push? You don't need to. You do it all in one step. Divided by what? 17.8. And then enter or equals. And what do you get? Okay, so Keelan, if we get a lot of numbers, does your 337th favorite math teacher want you to write out all those numbers? No. One decimal place. So, here's my calculator. Here's my calculator. Here's my calculator. You're seeing me tap the screen, right, Karen? This is not old people and technology. This is technology. Tap. Hey, there it is. $56.8 divided by 17. 78.817 blah 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 blah. Do I want blah 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 blah? No. I want one decimal place. So it's an 8. What's the next number? 1. Do I change the 8? No. So it's 78.8. What if I wanted 2 decimal places? Then I look at the 1. Is the next number bigger than 4? So that 1 becomes a 2. And we remember that from our very first day. Oh, look, it opened my calculator 3 times. 78.8. Always do it that way no matter what the numbers look like. Everybody cool? It's like 8 buttons. And it works every single time. Yeah? Okay. This should be your next page. This is the stuff that we use the math we just did to do. Okay? Now, as always, part of math is learning new words. So, I gave you a new word, ratio, and I tell you it's a comparison between 2 different amounts. Okay? So, in this room, it's full of people, right? Everybody agree? Okay. In this room, some of the people, let me double check, make sure there's more than one. Some of the people are wearing glasses. Does everybody agree? So there's an amount of people in this room with glasses, yes? And there's an amount of people in this room without glasses, yes? So I'm comparing two different amounts. Does everyone agree? Okay, so there's three ways to write that type of comparison. You can write it in words. Glasses to no glasses. All right? Or you can write it this way. Glasses, colon, no glasses. Or you can write it this way. Glasses over no glasses. Now, order matters. The first word goes first or in the numerator. The second thing goes second or in the denominator. So I said glasses compared to no glasses, yes? How many people in this room have glasses on right now? My grade 10s don't even think I'm a person. 5 glasses to how many no glasses? Yeah, if it's time to go, just go. How many no glasses? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Good luck, gentlemen. So we could also write that as 5 to 17. Or we could write it as 5 over 17. Does everybody understand? Everybody cool? Is there anybody in this room that is left-handed? 3 of you. So if I said right-handed to left-handed, there's 22 people in the room, or there was, those guys left, so let's say there's still 22. So if I went right-handed to left-handed, what would I write first? There's 3 left-handed people in the room. So I want right hand to left hand. Where will the 3 go? Will the 3 go where it is pink or where it is yellow? Pink. 3. And what will go in where it is yellow? What number? 19. Because there's 22 people in the room. Does everybody follow me? That is a ratio when we compare 2 of the same amount. Everybody cool? Okay. The next one is called a proportion. That's where we compare 2 ratios that are equal to each other. So, it would look like this. Glasses over no glasses. In our classroom, what was that ratio? 5 over 17, right? Everybody agree? Okay. So now I want to guess at how many people in the school wear glasses. Just hold up a sec. Everybody cool? Okay? So I would need to have glasses in the whole school compared to no glasses in the whole school. Does everybody follow me? Now, do I know how many kids don't wear glasses in the school? Do I know that? No. Do I know how many kids do wear glasses in the school? No, I don't. So I can't use this ratio, can I? But could I do this? What is the difference between those two ratios? What is the black one? You can read, it's glasses to no glasses. What is the pink one? Glasses to what? What's the 22? Right, that's to people, isn't it? Is everybody with me? Because I know how many people are in the room. Everybody cool? So, I actually should have done this in a different order. So, if I want to find out how many people in the school have glasses, would I use the black one or the pink one? The pink one. Because I know how many people are in the school, don't I? In our school, we have 1,390 students, and we have 57 teachers and grown-ups and people like that, right? So that is 1,447 people. Because we know that. Do we know how many of them wear glasses? So what do I put right here instead of a number? A letter. And what are we going to use? Come on! X. Do we know how to solve that? Do we know how to solve that? Sure we do. Is there a diagonal pair? Is there an extra number? So what do I do with my calculator? What do I hit? We just did it 3 times, kids. What do I do with the diagonal pair? Multiply them. 5 times 1,447. What do I do with the leftover number? Divided by 22 equals. Is that going to give me a perfect number? It's probably going to give me a decimal, isn't it? Can you have part of a person? No. So what should we be rounding to? Do I care about the decimals? No, I round to the nearest one person. So what does your calculator say right now? So 328.86. Your calculator has done arithmetic. Has your calculator done math? It's a trick question. The math is where you think to yourself, can I have 0.86 of a person? So what number am I writing there? 329. Now, let me ask you this. Do you think that an guess, or do you think that's the real number? That's a guess. We use this math. Governments, people, anybody who's dealing with money, they use this math to guess at the future. Everybody understand? That's why it's powerful. You can use it to plan. Everybody cool? Okay. So let's look at the next thing. It's a rate. That's a ratio comparing 2 different amounts in different units. Units means we are measuring different things. measure different things. Now, I'm going to give you a super easy one. You've all seen this sign on the street, and I've used this example. What does that sign mean when you see it on the side of the street? You can drive 50 kilometers per hour. Are kilometers something that we measure and count? Yes. Are hours something that we measure and count? Is an hour the same as a kilometer? No, one is time, one is a distance. So I'm comparing two different things. Does everybody understand? Now, I don't think very many of you drive, so we'll do a different one that matters to you. How many of you, if any of you, have a job right now? None of you have jobs? Okay. Have any of you ever had a job? How were you paid? Right. You were paid dollars per hour, weren't you? Are dollars hours? We say that time is money, but are they really? Can you go to the store and say, I've got 3 hours here and buy a Slurpee? No. So you're comparing two different things. Does everybody understand? That's a rate. But notice we still write it the same way. So does it follow the same rules? Yes, it does. Right? If you are driving somewhere at 80 kilometers in 2 hours, you go 80 kilometers in 2 hours, then how far would you go in 6.5 hours? Is it set up the same? Do I have a diagonal pair? Do I have a leftover? So could you tell me what this, I'm going to use Q, because I don't want to use X, Maria, because I'm tired of asking about your X. I personally have 6 X's. And I've been with my wife for 30 years. I had lots of girlfriends in high school and university. But then, got the right one. 30 years. But I mean, really. But so am I. So obviously, we would be together for 30 years. But seriously, folks, what are you going to punch into your calculator there? 80 times what? 6.5 divided by what? 2. And you would get the number. How much is it? 160? Exactly? 260. Exactly? No decimals? Oh, that's lucky. 260 kilometers. Even though the numbers are different, even though it's a rate instead of a ratio, as soon as you can set this up, you do the same math. Everybody understand? We're going to do this last one, then you're taking your brain break. I lied, I didn't give you a brain break, or I didn't give you a brain break yet today. I made you work straight through. That was kind of dinky on my part. So I'm going to give you a brain break now, as soon as we finish this box, okay? Now you all see the word rate again, yes? But this time it's a unit rate. A unit is when we have only one thing. So, Brock, do you remember what you were paid at your job? What were you paid? $20 an hour. I'm going to put some decimals in to make it more mathy. Brock was paid $20.85 for 1 hour. That's a rate, yes? Is this a 1? So this is a unit rate. He gets paid $1 per hour. Everybody agree? Everybody understand? About how many hours did you work a day? Okay, I'm going to use a decimal to make it better for me. So Brock worked for 5.5 hours a day. Where will that 5.5 go? Will it go on the top or on the bottom? Bottom, because the order has to be the same. Now, we don't write 5.5 because we're using decimals. So we would write 5.5 hours. How do we find out how much Brock makes in a day? Do we know? No. So we give it a letter. I'm going to give it J. No, wait, it's Brock. I'm going to give it B. Capital B. How do I solve it? Same way. Except it's even easier. Because do I ever need to divide by 1? No, I just do 20.85 times 5.5. And what do I get? This is going to be a trick question. Because money has how many decimal places? 2. So whatever comes up with your calculator, if it's more than 2 decimals, what do you have to do? Round it off. Will this come up to more than 2 decimals? I don't know. Let's see. Well, now my calculator's open but won't turn on. Got it. 20.85 times 5.5. So how much did Brock make in a day? Because all your calculators are showing you that number right now. How much did he make in a day? Well, we know it's 106. What's going to go right there? 8. Is everybody good? Awesome. Take a 3-minute brain break right now. Stretch, crack your knuckles, talk to the kid beside you. Discuss how you're so lucky to be in this class. I don't hear anybody discussing why they're so lucky to be in this class. Well, I'll tell you, kids, I'm lucky to have you in this class. And I'm not even joking, because last year when I taught workplace math, if I asked a question, not one person would say a word. Remember 2 days ago when I had to hold my breath and you didn't say a word? But look at you now. More than one person is talking. And it's only been 2 days later. And I didn't have to turn purple even once. Because I got to tell you, that was a long time. I wasn't prepared to hold my breath that long, but I did pretty well. Do you want to hear a funny story on your brain break? Just say yes, because I'm going to tell you anyway. My son used to like practicing holding his breath when he went swimming, because he liked the idea of those people that dive without scuba tanks, free divers. You seen those guys? You can hold their breath for like 20 minutes, like a seal. Right? Okay. My son thought that was a great thing to learn. So we'd go to the swimming pool and he would practice. Now I'm right beside him, so nobody thought anything of it. Yes? I walked into my bathroom when my son was about 3 and he was taking a bath. Guess what he was doing? Practicing holding his breath. So he was rolled over on his belly, face in the water, not moving. And I walk into the bathroom because I had to pee and we only had one bathroom at the time and he's only 3, so I don't really care. And I walk in and I don't look because I know where I gotta pee. I know where the toilet is. I'm not an Abbey senior boy who breaks the toilet up with a sledgehammer and wipes poo all over the walls. I go to pee and then I look into the tub. And what do I find? My dead son. Because he was face down, not moving. So I'm a father. You know I have a brain because my body moves. in my brain, I probably knew somewhere that he was practicing holding his breath. But what did I actually do? Ah! Grab him out of the tub. Are you okay? And you know what that little did? Got mad at me. Because he said he was on a record. He'd counted to 63. He was over a minute. And he was pissed off that I broke his record. Or I broke his chance at setting his own record. Turns out he's okay, though. Although, he's a little weird, so maybe he held his breath underwater a little too long, a few too many times. Maybe that's my fault. Oh, I recorded all that.